Hello my dear students. I know you already done that in-text questions of electrochemistry. So today let's do one problem with that finding out of electrode potential, standard electrode potential. So here is a question I am writing here. So here is the cell given. Find the E0 cell and this is the potential given, electrode potential is given. So what is our formula? How to solve? Pause it and solve this first. E0 cell equals to E0 cathode minus E0 anode. Okay, so which one is E0 cathode, which one is E0 anode? So this is E0 cathode, this is E0 anode. Okay, and from this is what? Reduction potential. This is again reduction potential. And which one is oxidation reduction potential? This one, because this negative sign. Okay, so this is what oxidation reduction potential that we have to usually written in here. So the cathodic part is this 0.80 volt minus of 0.25, right? So 1.05 volt. This is how you need to find the EMF, standard EMF of a cell. So next we will go towards the measurement. Measurement of electrode potential. Put it heading. Normally electrode potential, you can't measure the potential of half cell. Okay, so for that we need a reference cell, and from that reference cell we will calculate the half cell potential. Okay, so there is a popular reference cell, that is what? SHE. SHE is nothing but standard hydrogen electrode. Standard hydrogen electrode. It is nothing but gas and ion electrode. This is nothing but a gas ion electrode. Okay, so let me explain. Let me clean flash first. Okay, write some key points over SHE, standard electrode hydrogen potential. Write some points. First, it is a gas ion electrode. Okay, it is a gas ion electrode. Second, means is I am writing here H2 gas H2 gas and H plus ion aqueous. Okay, next it is a reference electrode. It can act both anode and cathode. Its standard oxidation potential and standard reduction potential is assumed not confirmed, assumed to be 0. That means half H2 equals to 0, E naught oxidation and reduction potential is 0. Understood? This is what SHE, standard reduction potential. By taking this, we can easily calculate the other half cells potential. Like zinc, we know that zinc's half cell potential is minus 0.76. From where we'll get this? From this, by taking this as a reference electrode, and suppose platinum, here platinum is taken as that electrode, because this is a gas ion electrode and we must need one metal. Okay, so platinum is taken as a standard electrode here, and the platinum has to gas 1 bar pressure, let's say, and standard case mein, and H plus aqueous solution, suppose nickel 2 plus aqueous and nickel solid. So here if you will need to calculate the potential of this, so this potential will be 0. So from that we can easily calculate the potential of this. If you will take in place of nickel, if it is zinc, then you can know the value of zinc, the potential value of zinc, standard potential value of zinc. If you will take copper, then you can know the standard potential value of copper. So by this we need to calculate, or we have calculated the standard value of these electrodes. Okay, so these are the 4 points that you need to remember. And what is the construction part? So it's very simple. You need to take here one acid which will give the H plus ion, and here you need to supply H2 gas, and here is the platinum electrode. Okay, so this is how the construction part. So these are the reaction. Note it. Next we will see the spontaneity of a cell reaction. So what is spontaneity? Spontaneous. So spontaneous relating to your Gibbs energy. Okay, when a cell is said to be spontaneous, when a reaction is said to be spontaneous, it is said to be spontaneous where del G will be less than 0 or del G will be negative. Okay, so what is del G? Gibbs free energy. Gibbs free energy is nothing but the useful work, the energy associated with the energy associated with the system, by the system, to do useful work. That is what Gibbs free energy. Okay, the useful work done by the system. Okay, the energy associated to do work, or free energy that is associated to do work. Okay, but for the spontaneous, that must be negative. That is what del G. Or you can write this del G equals to minus W, electrical work. As this is electrochemistry, we are working on electrical potentials. Okay, so electrical work, and remember all the electrical work is useful work all the times. So del G will be the electrical work, but we know that work done in electric field. What is work done? Or potential difference, that is del V equals to work done by charge. From the physics we know that. Or work done equals to charge into potential difference. Yes or no? So what is the charge over here? See, there is two electrodes, one is cathode, one is anode, right? Suppose one electron moves from anode to cathode, one electron. Suppose one electron will move. So the charge of one electron equals to, we know that 1.67. The charge of one electron is 1.67 into 10 to the power minus 19 coulomb. Suppose 1 mole of electron moves, for 1 mole of electron, the charge of 1 mole of electron is 1.67 into 10 to the power minus 19 into Avogadro's number, that is what, 6.022 into 10 to the power 23. Okay, so this value is approximately 96500 coulomb, and which is equals to 1 Faraday. Remember, 1 Faraday. So we can say that the charge of 1 mole of electron is 1 Faraday. That is what, 96500 value. Okay, suppose there is n mole of electron transferred from anode to cathode. How many? N number of. So charge will be NF. Yes or no? N mole of, for 1 mole, that is 1F. 1F. For n mole, that is NF. And what is potential difference here? Del V is the potential difference, and here we are writing the potential difference as a E cell. Yes or no? Yes. So what will be the work done over here? So this equation 1 becomes W equals to NF E cell. But for del G, it will be the negative value of this for spontaneous. So del G will be minus NF E cell. This is what the relation. Okay. And for the standard cell, what will be the value? Formula, del G not equals to minus NF E naught cell. Okay. So this value, del G naught value, E naught value, that you can calculate, and this del G value can be calculated if you know the value of E cell. And how will you calculate E cell? By the nonstick equation. This is what the nonstick equation. This E cell value, the calculation, finding out how will you calculate? By means of nonstick equation. What is nonstick equation? We'll see. Let me clean this. So nonstick equation. So from the equilibrium chapter of class 11th, we know that the Gibbs free energy, what is relations to 2.303 RT log Q. This is reaction quotient Q, and you can write instead of Q is product concentration by reactant concentration. Okay, so from this we need to derive nonstick equation. From this the nonstick equation came. Okay, so now put the value of del G. Del G, we know that minus NF E cell, del G naught is minus NF E naught cell. So see, minus NF E cell equals to minus NF E naught cell plus 2.303 RT log product by reactant concentration. Okay, now divide NF in both the sides and multiply with negative sign. So what you will get? E cell equals to E naught cell plus minus 2.303 RT by NF log product by reactant concentration. This is what you called equation 3, nonstick equation. This is what nonstick equation. So if temperature will be given, R value you know that 8.314, and then is the number of electrons, that F is the Faraday. Okay. So here you can see that 2.303 is a constant value, R value that you know that 8.314 joule per mole, and T is the temperature, that if that is given 25 degrees centigrade or 298 Kelvin, and Faraday that we know that 96500 coulomb. Suppose if temperature is given this, then there is one complex formula, simple formula, that is E cell equals to E naught cell minus 0.0591 by N log P by R concentration. So maximum time, about 98 to 99%, this type problem will come where the temperature is given that 25 degrees centigrade and you need to put this formula. Okay, if temperature is other than this 25 degree, maybe 30 degree or something else, then you need to put this formula. So this is what Nernst equation. Okay, is it clear? Okay. So this is a question of Nernst equation. So find E cell of a cell that given this half cell is given, Fe2 plus to Fe, reduction potential you need to find at 25 degrees centigrade. 25 degrees centigrade is given. So what will be the formula, and E naught of this is given. What will be the formula? E cell equals to E naught cell minus 0.059 divided by N log product by reactant. Okay, so product by reactant. So what is the reaction over here? Fe2 plus 2 electron, it gives Fes. Okay, so this is what your product, and this is what your reactant concentration you need to put. So always remember the elements in its free state, like solid state, iron is 1, the concentration of iron is 1. In its free state, all the metals is concentration is 1. So E naught cell is given, that is what, minus 0.45 minus 0.059 by N. What is N? C, 2 number of electrons, that is what, 2. Okay, log product concentration is Fe concentration, that is 1, by reactant concentration Fe2 plus concentration, that is given in your question, that is 10 to the power minus 2. Yes or no? So now you can solve 0.45 minus 0.059 by 2. This is log of 1 minus log 10 to the power 2. Okay, so what you got? This will become 2 log 10, and log 10 is 1. Log 10 is 1, so minus 0.45 minus 0.059 by 2 into 2. This value will come 2, so 2 cancel. So what will be the final value? Minus 0.509 volt. This is the value of E cell. Okay, this is how you need to solve. If you know E cell, now you can easily calculate del G also, because del G is minus NF E cell. You know the value of E cell, and you know F, you know. Calculate it and comment me what will be the answer. Okay, thank you.